Hello everyone, welcome to our channel Everyday E-Learning. In today's video, we are going to study how to convert binary number into decimal, octal and hexadecimal numbers, and then we are going to study how to perform binary addition and multiplication. So let us start with this example. We are given the number 1011 in binary and we have to convert that in decimal system. So for that, we can use the following procedure. At first, we'll have to give these numbers starting from the right side and moving towards left. They are position numbers. So this one is 0, this one is 1, this one is 2, and this one is 3. Now, what we'll do is take the first number and multiply it with the base of the binary number to the power the position of this one. Plus, we take the next number into the base to the power its position, plus we take the later number and again do the same. We take the last one, which is 1, into the base to the power its position. So we have 8 plus 0 plus 2 plus 1, and finally we have 11 in decimal systems. Now the next example, we will convert a decimal number which is in binary format to decimal system. The number is 0.1011 to decimal. So for this, there is just a little change in the rule. So we will now give the position numbers starting from left to the right. So this one will be -1, this one will be -2, this one will be -3, and this one is -4. And then we perform the same thing as we did before. Take the first number, multiply with base to the power its position number, plus take the next one into the base of binary number to the power its position, and then the next one, and finally we have 1 into base to the power its position number. So if we do the calculation here, we have 0.5 for the first one, then we have 0, plus we have 0.125, and then finally if we do the calculation for this one, we'll have 0.0625. So if we add them up together, we get 0.6875 in the decimal format. So these two, number 1 and 2, we did for binary to decimal systems. This one is also same, binary to decimal. Now the next ones, we will do binary to octal. So let us take the third example. So for this one, we are given 1 1 1 0 0 1 0 1 1 1 0, which is the binary number, and we have to convert that into octal number of base 8. So the octal number has base 8 as we studied that before, and now we will divide this whole binary number into 3 separate bits of each. So we'll take first these 3. Let me take a different color. I'll write it from here, 0 1 1, and then we'll take these 3, 1 0 1, and then we'll take these 3, 1 0 0, and finally this one, and we'll include a 0 before that to make it 3. So if we now convert all these to decimal, we'll get, for this one, if we convert 110 to decimal, we get 6, and if we convert 101 to decimal, we get 5, if we convert 100 to decimal, we get 4, and if we convert 011 to decimal, we get 3. So if we convert this whole number into octal, we end up with 3, 4, 5, 6 with base 8. Therefore, for binary to octal conversion, we divide the numbers taking 3 separately, and then we convert the decimals into we convert the binary numbers into decimals, and then we write the numbers together to get the octal number. Now, for our last example, we'll learn how to convert from binary to hexadecimal number system, and we'll take the following example: 1100, and we have to convert this number into the hexadecimal number. So the base of hexadecimal is 16, and we will divide the given binary number taking 4 separate numbers each. So at first we take this one, 0 1 1 1, and then we take this part, 0 1 0 1, and then we take this one, 1 0 1 0, and then we take the remaining one, 1 1 0 0. And if there would be any case where you have 2 or 3 digits missing, you can just add 0 before them. Now we'll just have to convert these binaries into their respective decimal ones, and if we convert this one, we get 7. For this one we get 5. For this one we get 10, and for this one we get 12. Now we know that in hexa system there are a change in the ones after 9, so A is denoted as 10 in hexadecimal system, and for 12 we use C. So if we convert this whole number of binary into hexadecimal, we end up with CA 5 7 and base 16. So for all these conversions, you just need to remember a table, or you can do it yourself and keep it beside while doing this type of problems or conversions. So I will just draw the table now. So you can just remember this table of counting in binary. Remember this one, as it will help you to do the conversions pretty easily. So as you see that the number starting from 0 to 15, the total 16 numbers are given in this table along with their conversions chart. So you can just easily recall it, and then you can do the conversions pretty easily. Now let us move on to our next part, binary addition. So for binary addition, we need to remember the following 4 basic rules, that are 0 plus 0 equal to 0, 0 plus 1 equal to 1, 1 plus 0 is equals to 1, and 1 plus 1 is equal to 1 0. So this is the different one, and we'll learn about the binary additions using adder in our later videos, but for now you remember this one. And the one that comes in the right is called the sum bit, and this is called the carry bit. So if we remember these 4 rules, if we remember these 4 rules, then it will be very easy for us to do any sort of binary addition. Now we will take the following example. Let us add 1010 with 1110. So if we convert it into decimal, we'll have 10 plus 14, which is 24. Now let's see if we get the same result here. So if we add 0 and 0, according to this one, we have 0. If we add 1 plus 1, we have some bit 0 and carry 1 will come here. So 1 plus 0, we have 1, and 1 plus 1, we get 0 and carry 1. And again, we have 1 plus 1. So that produces some 0, and some 0 will be added with this one and we'll have 1, and remaining carry will be here. So this is our result, and if we convert 24 into this one, we'll have 1 1 0 0 0. So now we'll see binary multiplication. Binary multiplication. So for binary multiplication, we have again 4 basic rules, and they are 0 into 0, we have 0. 0 into 1, we get 0 again. 1 into 0, again that's a 0, and 1 into 1, that's 1. So these are the following 4 rules that are to be kept in mind for performing a binary multiplication. Now let us take an example. Multiply 1 1 1 with 1 0 1. So 111 is in decimal 7 and 101 is 5. So 7 into 5 is 35 in decimal. Now let's see if we get that in binary. 111 into 101. Now if we multiply with this one first, we have 1 into 1, we get 1 for all. Now we put a cross sign here and we multiply 0 with the 3, so we have 0 0 0, and we take again 2 cross signs here and we multiply 1, so we have 1 1 and 1. Now we add them up together using the rules of binary addition. So we have 1 here, and we have 1 plus 0 again 1. 1 plus 0 is 1, and 1 plus 1, we have carry 1 here and some 0, and then 1 plus 0 is 1, and again 1 plus 1, some 0 and carry 1, so this one will come here. So if we convert this one to decimal, we get 35. So I hope these are all clear to you. If you have any questions or confusions, feel free to write down below, and we will continue this playlist with the other videos. So don't forget to like and subscribe. Thank you very much.